Hey guys, Mr. Backward here. In this video, we're going to look at slopes of parameterized curves. So if we're looking at a parameterized curve where it's defined as x of t comma y of t, that's differentiable at t if both those x and y functions are differentiable at t. So at a point on a differentiable parameterized curve where y is also a differentiable function of x, then we've got these derivatives dy dt and dy dx. They're related by the chain rule. So we can think about it as dy dt being equal to dy dx times dx dt. And as long as dx dt is not 0, then we can divide both sides of this equation by dx dt to help us solve to find dy dx. So as far as finding a derivative dy dx parametrically, if all three of those derivatives exist and dx dt is not 0, then in order to find dy dx, what we're going to do is take dy dt and divide it by dx dt. Now all of that was pretty heavy mathematically, so let's see if we can look at an example to really illustrate what's happening there. So we're going to be differentiating with some parameters. We want to find the line tangent to the right-hand hyperbola branch defined parametrically by x equals the secant of t and y equals the tangent of t on the interval of t values between negative pi over 2 and positive pi over 2. And we're going to look specifically at the point root 2 comma 1, which is where t is equal to pi over 4. So what we just said on the previous slide, if we want to find dy dx, so the derivative of y with respect to x, what we need to do is take dy dt, so the derivative of y with respect to t, and divide it by dx dt, which is the derivative of x with respect to t. So if we start differentiating things in here, I'm going to start on top. It says do the derivative of y with respect to t. So we're looking at this y chunk first, where it's tangent of t. If we do the derivative of that tangent of t, well, the derivative of a tangent is a secant squared of t. And then on the bottom, I'm supposed to look at that x parameter and differentiate it with respect to t. So the derivative of a secant is going to be the secant of t times the tangent of t. But now there's some simplifying that can happen in here. We've got secant squared on top and we've got another secant on bottom. So we can cancel out that secant on bottom with one of those secants on top. So this is the secant of t divided by the tangent of t. But there's even more simplifying that can happen in here. We know that the secant of t is 1 over the cosine of t, and the tangent of t is the sine of t over the cosine of t. So we've got these fractions in here, and we don't typically like to divide by a fraction. So instead of dividing by that fraction, I'm going to multiply by the reciprocal of that denominator fraction. So now we've got a cosine on top and on bottom that are going to cancel each other out. So this simplifies down to just 1 over the sine of t, which we should recognize as the cosecant of t. So this is our dy dx, this cosecant of t. But now if we want to find the slope at this specific t value of pi over 4, we need to plug pi over 4 in for our t here. So it's the cosecant of pi over 4. Now on the unit circle, pi over 4 has an ordered pair of root 2 over 2 comma root 2 over 2. And the cosecant is the reciprocal of the y value. So if I look at that y value and I do its reciprocal, this is going to be 2 over root 2, but we're going to clean that up by rationalizing the denominator. So in order to do that, we're going to have to multiply top and bottom by root 2. So we end up getting 2 root 2 over 2, but those 2's cancel out, so we just get root 2 as the slope at that specific t value. Now, we're trying to write out an equation for a tangent line. We were given a point earlier, root 2 over 2 comma 1, and we just found the slope using this specific t value of pi over 4. So now we're going to have to do some point slope stuff. So I'm going to do y minus the y value from the ordered pair, which is 1, equals our slope, which we just found to be root 2, times x minus the x value from that point, which is root 2. I'm going to start by distributing that root 2 on the right-hand side. So y minus 1 equals root 2x minus, if we take root 2 times root 2, we just get 2. But then I need to get rid of that minus 1 by adding 1 on both sides. So I end up with the equation y equals root 2x minus 1. So that's our equation for the tangent line at that point root 2 comma 1 using that t value of pi over 4. That's going to be it for this video. Thanks for watching.